we have this challenge that we want to look at today, and it's a great one. It's to do with coordinates, which are fairly logical if you work your way through them and you understand how they work. But when you look at this one, there just doesn't seem to be enough information to answer the question. We have got our y-axis with no numbers labelled on it. We've got our x-axis with no numbers labelled on it. We've got 2 points A and B that we do know the coordinates from, and we've got point C, which is the one we need to find, which is part of a different shape. What clues have we got? Okay, so we'll have a look at this. Before we get to the problem though, I'm going to go through one or two things that will give us the basis to solve this problem. So let's start looking at this question. What we have to do with this question is we need to work out the coordinates of the 4 vertices of the shape. So the vertices are the corners, so we're looking at the 4 corners of this shape. We work out the coordinates by, as you should know by now, walking along the corridor and then going up the stairs. And what that means is we work out the x value first, so we look at the x-axis to get the value, and then we find the y value. So let's do that very quickly for one of the vertices. Let's have a look at this one. So we are going to look at this vertex here. So how do we work out what this vertex is? Well, first of all, we go along the corridor. So we see how far along it is until we get to that vertex. And I can see that I have to go as far as 7 because it's in that line. It's on that line where 7 is. Okay, so that is my first value. My first value is 7. So let me just quickly write this down. We always start with brackets. We have 7 is our x coordinate. We always separate the x coordinate and the y coordinate with a comma. So I've got a comma ready for my next part. Okay, so once we've done the x coordinate, we then need to see the y coordinate, which is going up, and we see how far up it goes. So again, when I'm looking at my coordinate, I can see that it goes as high as the 4 in the y-axis. If we continue to go, we can see it's on that same line. That same line there. So I have got 4 in my y-axis. So I can add that to my coordinate. Get this in the right position. So we've got 4. And don't forget to finish off with the brackets. So there is my coordinates for that first corner or that first vertex that we have pointed out. Okay, you can continue to work out the rest. I will pause the video. You pause the video as well and see if you can work out what the other 3 vertices are. Okay, did you manage to get the answers that we were looking for? If we just do a little bit of thinking about what we've got, let's have a look at how they work, because you can see a sort of pattern with these. So with my arrow, I can see that I have got not what I'm looking for. Come on, arrow, that's the one I want. So we can see that we've actually got 2 vertices on 3 with a coordinate of 3 in the x-axis because they're both on the same line. 3, 4 and 3, 8 are both at position 3 on the x coordinate. We've also got the same sort of thing happening over here in the y coordinate, where we've got these 2. They've both got 4 in the y coordinate, 7, 4 and 3, 4, because if we continue along we can see that they are in the same row as 4. So there's that pattern, and that pattern can help us with our calculation later on. Okay, so if you got those, well done. Okay, let's have a look at this problem that we have here. Now this problem is confused by the fact that we don't have any labeling on our x-axis or our y-axis. We don't know where everything is. So what we can tell though is we do have enough information to say things like, well, if this point here is 12 along on the x-axis, this point must also be 12 along on the x-axis. So this must be 12 something, and it must be a number less than 10 because it's closer to the x-axis than the other one. So this will be 12 something. Similarly, we can say the same about over here. We can work out similar over here because this one up here is 4 along on the x-axis and its coordinates are 4, 10. This one here will also be 4 along on the x-axis, and because it's 4 along on the x-axis, it will be open brackets 4 comma something, and that something will be less than 10 because again it's below that. So how does that help us with our coordinates now? Do we have enough information to work out the coordinates here? No, we don't, because all we can say so far is that it is this one is 12, but we don't know what that is, and this one here must be 4, but again we don't know what the y coordinate value is. We need a little more information to get that y value. We can guess, but that's not the best way of doing it. We need more information. Now fortunately, the problem that we are going to look at gives us that extra information that we will need to solve the problem. So let's go back and have another look at our problem. Okay, so here we are with our original problem that we were looking at, and let's see if we can help ourselves now to solve our calculation or our problem. What information do we have that can help us? Well, again, let's just have a look at what we got. Again, we got our x-axis and our y-axis with nothing labeled, but we do know that these 2 points A and B are both at position 10 on the y-axis because they are 3, 10 and 9, 10. So that's something that we know. Anything else, and we're looking for C, the y-axis must be less than 10 because it's further down nearer to the x-axis, so it's going down here towards there. So that's something that we know. What else do we know? We know that A is 3 along the x-axis and B is 9 along the x-axis. So how we can work out how long this line is, how long it is from A to B, because it goes from 3 to 9. So I would say to myself that if I want to work out that, I would be doing 9 take away 3 equals, and that equals 6. So we know that the length from here to here is 6, which means that this must also be 6. And then because we know that from our information that we've got here that they are 2 identical rectangles, that means they are the same size. We know that the distance from here to here is also 6. Interesting. So if this point here is 9 along the x-axis, along here is going to be another 6 along the x-axis. 9 add 6. We can do that quite easily. 9 add 6 equals, you should be able to work out what the X value is here, now that we've done that. Okay, so that will give us, in fact, if I do it from here, 9 add 6, that will give us the X axis for that position. Okay, so that's pretty good so far. But what about these Y values? Well, for that, we need to have a look at the information that we've got down here. And it tells us about the relationship for our rectangle between its length and its width or its breadth. So we know that the length of each rectangle is double its width. So we know the length of the rectangle because we worked it out. We know the length of the rectangle is 6. So its width is going to be half of that. And half of 6 is 3. So we know that the distance from, let me just get an arrow, the distance from here to here is going to be 3. So at the moment it's 10 on the y-axis. If we go down 3, what's that going to be? Well, it's going to be 10 take away 3, and 10 take away 3 is 7. So because I know that what my y-axis is going to be here, and I already know my a-axis because it's the same as this one, I know that this point here is going to be 3 along the x-axis, and for my calculation 7 along the y-axis, so it's 3, 7. I've now got enough information to work out all the other vertices on these shapes, and we will definitely be able to get to this now. Okay, I hope that helps you with your calculations. There's a lot of things to think about, but all the calculations that you need to do are really simple things like 9 take away 3 and 10 take away 3 and 9 add 6. There's no difficult calculations for you to do. It's just thinking logically and using the information that you've given. Good luck. I hope to see your answers in the blog posts.